If we look at the script that's conducting our sensitivity analysis, we notice that we have most of the configuration of our analysis defined in the first few lines of code. For example, we've defined the times at which we want to know the reactant concentration in this line of code, and we've defined the collection of rate coefficients and initial concentrations that we want to use for performing our full factorial design of our sensitivity analysis. So it's relatively straightforward change of values here, and our script knows how to rerun based on how we've changed those values. For example, we could add another rate coefficient here, like 0.01, to our list of 3. And we could also change this high value for our initial concentration. Say we want it to be 150 instead of 100. And our script knows how to deal with this. It knows how to handle however many rate coefficients we give it, and it knows how to handle however many initial concentrations we give it, and whatever those values are. So if I rerun this analysis code, and then I rerun my product code for generating the graphs, then I can go to my product and my visualization, and I can see now I have another line representing another decay rate at 0.01. And my code is able to figure that out just from changing those atomic vectors at the beginning of the script. Also, we have a 25 milligram 50, and now our peak here is instead of 100, now it's 150 for our initial concentration. So we already have code that's capable of adjusting to whatever we want to configure in terms of the times and the rate coefficients and the initial concentrations. But let's say we want to be able to do this without hard coding these values. Right now, if we want to change this, we actually have to change our code. Well, if we truly want this to be a fully automated workflow, perhaps we could make the values for these variables something that are read in as a configuration by this code from files that are in our pipeline input. So we have this input folder, which is where we put the inputs to the workflow that define how that workflow is going to operate. And we can do that by, in this case, we just need some pretty simple text files that keep track of some numbers that we might want to import or read in from files in our input directory. So first of all, we want to think about what those files are going to look like. In this case, we're just talking about a series of numbers, so perhaps comma delimited numbers, very similar to what we have here, can just go into a text file in our input directory, and then we can use some sort of function from R to read those in. So first, let's go ahead and create a text file, and I'm just going to use RStudio for this. Notice there's lots of things I can create here. I'm clicking on this little arrow next to a new entity button, so I need to create a new thing here, or create a new file of some type. And notice I have an option of just a text file, just a plain text file. So I'm going to select that option, and notice it says it's untitled at first, so I need to tell it where I want to save this. So if I hit the save button to save this file is not going to go into protocol. This is input data for my workflow. So I need to go back to my root of my pipeline and go to my input folder. And then I need to decide what I'm going to call this file. So let's say this is going to be my const inits. So I might as well call it something that's logical to me and what my code is reading, and call it my const inits. And I have to decide what extension to use. Now, the extension you put on a file name is part of the file name. You could put an extension on there that doesn't make any sense relative to the file name. But since this is a text file, I think I'm just going to call it .txt. That's a really common extension to use in the file name to specify or to give a hint to the operating system that what you're creating is a text file. So now the name will change on the tab to where it's saved, and I can see in my input folder, I now have a file called const inits. And I'm going to go back to my code, and I basically want to use the same format that I'm using in my code because I know that there's an R function I can use to read in comma delimited values into an atomic vector. So I'm going to copy these numbers as I currently have them. Oh, I'm sorry, that's not const inits. I need my const inits. That's these. I'm gonna copy these numbers as I have them here, and I'm just gonna put them in this text file. And then I'm going to save it. So I have 3 values separated with commas in this file called const.inits.txt in my input directory. Now, instead of assigning those values with hard coding here, I can assign these values using a function from R called scan. So I'm going to do help on scan. It says read data into a vector or list from the console or file. We see some of the arguments that we can send to scan to get it to do what we want. First, we have to tell it the file name that we want to read the data from. Another important argument here is sep, which the sep tells R which character is used to separate the values that it's reading into a given atomic vector. So, in place of this hard-coded definition of 3 values using the C function, I want to call the scan function. I know I'm going to need space for this, so I'm going to go ahead and break the arguments out into individual lines. And I'm going to set the file argument to, again, I want to use relative paths here. So in this case, I need to go to the root of my pipeline, which means my current working directory. I can do a get wd. Because of the way I opened up R with the project file, I know protocol folder is my working directory. So I need to go to the parent of my working directory, which is the root of the pipeline. And then I need to go to the 1_input. And remember, RStudio knows I'm starting to type a path, so it's suggesting that maybe this is what I want to type, because there's only one folder of the parent of my working directory that has a 1_ at the beginning of it. So I could just hit tab here to autocomplete. Oops, I used the wrong slash. Let me fix that. And then I need to tell it which file I want to read in. Again, I've created that const.inits file already, so it's there. And again, RStudio knows I'm typing in a path, so it's saying, hey, maybe you want to put in the name of one of these files, and this is the one I want to read. So that's the file. The other thing it really needs is the separator. What is the character that separates different values of the atomic vector I want to read in? And remember, in this case, I left a comma there. So I want to separate the values with a comma. So the character I want to give it as the separation character is a comma. So I need to put a comma in quotes because that needs to be a character string. Now I can see how this works. I'm not using any variables here, so nothing has to be defined for me to see if this works. So I can double check that it works by highlighting the code that I want to run and hitting this run button. Oops. There we go. So it ran that code, and notice it gave me a little message in the command line here where it says I just read 3 items. So that's a message that gets sent to the standard output of the command line when I call scan that tells me that it read in 3 items, which makes sense because there were 3 numbers. I can also look at the value of const_inits, which is the variable I just assigned to what I read, and notice I have an atomic vector with 3 values, just as I did before, except now it's not hard-coded, it's reading them in from that file. So that means I can get rid of this because I'm now reading that into a file. So let's do that again, but let's do it for the rate coefficients. So again, I'm going to need a new text file. I'm going to save this. Just so I don't get confused, I'm going to call the file name something similar to the variable name so I can remember what it is. Again, I'm going to call it .txt because this is a text file. I want to copy and paste the comma delimited numbers here. And I can save this file. And I'm just going to go ahead and use this scan that I've already typed in as a template and replace this call to C with the scan. Except in this case, instead of reading const inits, I want to read the rate coefficients file. Also, another thing we can do with these scans is that when we're running a program, we don't necessarily want it to be sending that red 3 items to the console every time it reads something. And you can control that with the scan. Notice the scan has an argument that says quiet right there. And by default, the value of quiet is false, which means it's set to a value of false, which means it's not going to be quiet. And quiet is just telling it not to send things to standard out. So if I want it to be quiet and not send a summary of what it read to standard out, then I can set quiet to true. And that just will prevent this red 3 items from coming up every time I run this script. So I'm going to do that for both of my calls to scan for the rate coefficients and the const inits. So again, I can just run this code. Another way to run code, you can do this on a PC, is hit Control Enter. You can do it on a Mac too, but I can't remember the key, but you should be able to look that up for a Mac. There is a hotkey for running code you have highlighted. On a PC, it's Control Enter. So you can see it ran rate coefficients, and I can just make sure that those values are what I am expecting, and they are. There's 4 values going from 0.01 to 0.2. And finally, let's say we want to also be able to set our time, configure our times. And we want to be able to read in data from the input to say which times we want to plot our sensitivity analysis over. So I'm going to do that by reading in an atomic vector that I'm going to call times config. Again, I'll use scan here from one of my other calls to scan as a template. But in this case, it's not going to be just a list of numbers. It's going to be a list of numbers corresponding to the configuration of the seek function. So I'm going to call the file that I create timeconfig.txt. Again, it's just going to be a list of comma delimited numbers. But in this case, I'm going to have these 3 numbers correspond to the from, to, and by values here in that order. So I'm just going to copy these values, create a new text file. I'm not going to worry about these names. I'm just going to read in those 3 numbers. Going to save this file. Again, I called it timeconfig.txt is what I'm expecting to read in. And again, that's going in my input directory. So now I've read in a vector. I'm calling timeconfig from the file name. I'm calling timeconfig.txt. And I'm expecting those 3 values to be in the order of the from, to, and by arguments for seek, or for the sequence. So instead of these hard-coded numbers now, I can put in timeconfig the first element, timeconfig the second element, and timeconfig the third element. Because I know when I read this in, this will be element 1, this will be element 2, this will be element 3. So first of all, we have not changed any of these values, right? We've just copied them from, they used to be hard-coded, but now they're in these text files that should get read in by our code and then used by our code for the configuration of our sensitivity analysis. One last thing that I want to do here is try to make this fully automated, and maybe I can make this so I can only need to run one script. Now, if you recall, we created a separate product script in our protocol folder because we recognized that we didn't necessarily want to rerun our analysis every time we wanted to rerun how we made our graphs. And that's still fine. We can think that way, and that we have this separate product script to make it really easy for us to regenerate our graphs without having to rerun our analysis. And we can leave that alone. However, we might think that, well, if generating the graphs doesn't take that much time, maybe we think, well, every time we run our analysis, we do want to regenerate graphs. So we don't necessarily want to rerun our analysis every time we generate a graph. But when we do rerun our analysis, every time we do that, we do want to generate a graph. So hopefully that makes sense. If we leave product.r alone, that means we can generate our graphs without rerunning our analysis. But we can put a line of code at the end of analysis that will make sure the graphs are regenerated if we ever rerun our analysis. And this is the kind of thing you might want to do if making the graphs is a trivial amount of time and computation relative to how much time it takes to run the analysis. So how do we do that? Well, there's another function in R called source. And source is a function that lets you call an R script that is contained by another file and run that R script. And that's exactly what we want to do here. If we're done with our analysis, we've completed our analysis and we've saved the results, we can just run our product R script from our analysis R script. And we would do that by calling the source function, giving it the argument file, and then the path to the file. Now in this case, it's in the protocol directory, and our working directory is the protocol directory. So we don't need to go to the parent directory, we need to go to the current directory. So I need to put a // which means my current working directory / and then whatever file. And if I hit the tab key, again, RStudio knows I'm typing in a path, and it's going to make a suggestion. Do you want to use one of these existing files at that path? And I do. I want my analysis script to run my product script. Now, in reality, this will still work if you don't put the // because it's going to look in your working directory before it looks anywhere else for this file if you would run it this way. I still like to put the / because it just makes it super clear that I'm using relative paths and this code is designed to work with relative paths. Okay, so let's review real quick what we've changed here before we run it. We basically said, well, we don't want to hard code all these values because we don't want to change our code if we want to change our configuration of our sensitivity analysis. We'd rather just be able to change one of these text files that we read in to reconfigure our sensitivity analysis. And also, we've recognized that, well, maybe if we rerun our analysis, every time we do that, we do want to regenerate our product, which is in this case, generating a graph of the results of our sensitivity analysis. So we've added this line of code at the end that will automatically run the product script after we have completed our analysis script. So that means if I run this analysis script, I should be able to go back to my PDF of my plots, and it should look exactly like it did before. So remember, I copy the configuration of my sensitivity analysis from the hard coding into those files, so nothing should have changed here. It's just different in how it does its job. And I can also look at the folder to confirm that, yes, it was at 1325 today, and it's 1326 now, that this visualization.pdf file was regenerated. So it did run this product.r. Now, just to convince you that this is working, I'm going to go ahead and delete this file. I should probably close it first. So I'm going to delete my visualization file just to convince you that when I rerun this, it regenerates that visualization file. But also, let's test our configuration. So let's do a few things differently. Let's say, well, this is too dense. I don't really need to know every half of a minute what's going on over 60 minutes. It's fine with me to know what's going on every 1 minute. So I'm going to change the third value of my time config to 1 because I know that is going to end up defining the by argument of my sequence. So I know that I'm going to be outputting every 1 minute instead of every half minute. So I can save that. Let's say, well, I've got 4 rate coefficients, but I've decided that this 0.01 is too small. I want to make that 0.025. And let's just say, I'm going to save that file. const inits that I want to see what happens if I add another value here. So I'm going to add a fourth value at 300, and I'm going to save that. So I have to make sure all of these are saved, because if they're not saved, then the file that's on the hard drive is not going to be the same as what I'm seeing on my screen. So these have all been saved. That means when I run my code and it reads those files, it'll get the current values. And I'm going to run analysis. And because I am now running my product at the end of this script, I should have a new visualization file in my product directory. And now I should see 4 rate coefficients. This time, instead of 0.01, I'm at 0.025. And that indeed is falling a little bit faster than the 0.01 is, which makes sense. Also, I have 25, 50, 150, and now I have a 4th figure showing an initial concentration of 300 milligrams per liter. And I should also have that for my filtered data because of adding the iteration that will allow me to see all my filtered results as well as my unfiltered results. So now we have a fully automated workflow where the configuration is getting read in from input data in my input folder. And my script is now running without any hard-coded values, so that if I need to change the configuration, I can just change these values and I don't need to change my code.